The rules are strict: 2-3 sentences, 30-45 words in present tense with a single sensory detail. No fluff like imagine or channel intros. Must grab attention in under 3 seconds. A radio telescope records a burst. Static crackles across the speakers, then silence, sharp and sudden. The signal arrives from deep space, a flash older than humanity. Astronomers had long known the universe held less visible matter than predicted. Stars, gas, galaxies added up to only half the expected baryonic mass. The rest, the cosmic inventory insisted, must be hidden. But where? It vanished into the void between galaxies. The search was like hunting ghosts in a storm. Gas between galaxies was too thin, too hot, too faint to see directly. Telescopes scanned the sky, but the missing matter remained invisible. It was a puzzle with half the pieces missing. Then fast radio bursts arrived. These intense, millisecond flashes traveled billions of light years. Their signal stretched as they passed through space, revealing the density of electrons along the path. The dispersion measured the unseen gas. Astronomers used this trick like a cosmic ruler. They measured bursts from distant galaxies, mapping the gas in their path. Data streams flowed through supercomputers, revealing a web of faint gas filling the void. In 2020, a study called the Mackworth relation confirmed it. The missing baryons were there, woven through the cosmic web as warm, hot gas. The universe hadn't lost half its matter. It had simply hidden in plain sight, waiting for the right tool to find it. The dispersion matched the predicted amount. The ghost was found. The data streamed across the screen in real time. A single fast radio burst detected by the Parkes telescope pulsed through the receiver. Astronomers held their breath as the dispersion measure calculation finished. 10.25. The number glowed on the monitor, matching the predicted value from Big Bang nucleosynthesis. No more ghost, no more gap. For the first time, the cosmic ledger balanced. The gas wasn't missing, it had been hiding in plain sight for decades. This invisible gas exists in the cosmic web's filaments. It's the warm-hot intergalactic medium, or WHIM. Temperatures range from 1 million to 10 million degrees Kelvin. Hot enough to emit faint X-rays, but so thin, just 1 atom per cubic meter, it barely interacts with light. Previous X-ray telescopes like Chandra scanned galaxy clusters, missing the diffuse gas in the vast spaces between them. The voids were empty on the screen, but not in reality. For decades, astronomers hunted dense pockets of gas. They searched for clusters, for glowing halos around galaxies. They found nothing matching the predicted half. Each failed observation deepened the mystery. The gas was there, but it refused to be seen. Its signature was too weak, its structure too vast for telescopes designed to find stars. It was the ultimate silent witness, existing in the spaces where no one looked. The Mackworth relation study confirmed the solution. The dispersion measures from hundreds of fast radio bursts directly mapped the electrons in the WHIM. The density matched the missing baryons exactly. The leading explanation holds. Gravity pulled matter into the cosmic web's filaments during the universe's formation. The WHIM is that structure itself. Some gas clings to faint galaxy halos, but the bulk fills the vast, dark spaces between clusters. The universe didn't lose matter. It hid it in the skeleton of its own structure, waiting for radio waves to reveal the pattern. The ghost was found. The web was real. Telescopes strained against empty space. They scanned galaxy clusters, haloed spirals, even cosmic voids. Every spectrum showed less gas than expected. The missing half refused to glow, to scatter light, to scream its presence. Astronomers adjusted instruments, reprocessed decades of data. Still, the void stayed silent. The gas wasn't hiding in pockets. It was woven into the fabric itself, too diffuse for direct detection. Then came the bursts. Short, sharp, arriving from deep space. Fast radio bursts, FRBs, cosmic whispers cutting through the radio static. Each burst signal stretched as it traveled through electrons in the intergalactic medium. The degree of stretching, its dispersion measure, was a fingerprint of the gas it passed through. Astronomers mapped these fingerprints across hundreds of bursts. They calculated electron density along each line of sight. The numbers didn't just hint. They lined up perfectly with the predicted missing baryons. The cosmic web's filaments, long theorized as gravity's scaffolding, held the gas. Its density matched the deficit exactly. The WHIM wasn't just possible, it was the only explanation that fit. This wasn't a guess. It was a direct measurement. The Macquart relation study confirmed what decades of indirect evidence suggested. The universe hadn't lost matter. It had hidden it in the vast, warm hot gas filling the spaces between galaxies. The skeleton of the cosmos held the missing flesh. No more hunting for ghosts in the wrong places. The proof was in the radio waves, the measured dispersion, the precise match to cosmic predictions. The missing matter was found, not as a single entity, but as the pervasive, invisible medium of the cosmic web itself. What new shadows will we finally see with the next tool we build?